In the summer of 1996, a machine crossed Belarus, carrying a 40-meter passenger ship. 88 tons of riverboat, strapped into cradles, moving down public roads at walking pace, with the power lines switched off ahead of it so it could pass underneath. It was going to a lake, where a company had bought the boat to turn it into a floating restaurant. That is not what the machine had been built for. 11 years earlier, in a shed in Minsk, the same vehicle had been assembled for one purpose: to carry an intercontinental ballistic missile weighing 104 tons out into the forests of the Soviet Union, and to keep it moving after a nuclear first strike. 28 meters long, 24 wheels, every one of them driven, 16 of them steering. A gas turbine taken from a tank, spinning a generator, feeding an electric motor inside every single wheel. 2 of them were built. In military trials, they covered between them a little over 2,000 kilometers. Then the program was cancelled and they were parked. So when that boat needed moving, there was exactly one object in the country capable of doing it, and it had been sitting on a factory yard for years with nothing to do. The journey was 250 kilometers. It went almost perfectly, and it was the last thing the machine ever did. This is the story of 3 attempts to put an impossible missile on wheels, and the railway line that made all 3 of them pointless. It begins with a decision made in Minsk in the summer of 1954. In July of that year, inside the Minsk automobile plant, the state set up a small separate design office with a deliberately dull name: Special Design Bureau No. 1. Its job was heavy artillery tractors, machines to drag guns through mud. The man they put in charge was called Boris Shaposhnik. He was 51. He would run that office for the next 31 years, until the last year of his life. And in that time, the dull little bureau for artillery tractors quietly became the place where the Soviet Union solved one of the hardest problems it had. The problem was this: a missile in a concrete silo has one fatal weakness. The enemy knows exactly where it is. Through the 60s and 70s, American guidance got better, and then better again, until a silo stopped being a fortress and started being an address. There is only one real answer to that, and it is not thicker concrete. It is movement. If the enemy does not know where the missile is right now, he cannot destroy it in the first minute of a war, which means he has to live with the knowledge that it will still be there in the second. That is the whole logic of the Cold War in one sentence. Not defense, survivability. So the missile had to move, and something had to move it, which meant somebody had to build a wheeled vehicle capable of lifting an object the weight of a loaded railway carriage and driving it into a forest. That is what Shaposhnik's bureau did. Through the 50s and 60s, his office produced a family of enormous multi-axle carriers, and they worked. They became the flatbed under the rocket in every parade the West ever filmed and studied. But every one of those machines had a ceiling, and in the early 80s, the state came to Minsk with a requirement that went straight through it. The missile was the RT-23, 104 tons on the pad, 22 meters long, 10 independent warheads, a reach of more than 10,000 kilometers. What made it unusual was not its size, it was the plan around it. One missile, the same missile, was to be based 3 completely different ways: in silos, on railway trains, and on roads. 3 platforms, 3 sets of engineers, 3 claims on the same budget. It is tempting to read that as thoroughness. It is more honest to read it as a competition nobody had yet announced the result of. The rail version you may already know: a train of what looked like ordinary refrigerator cars wandering the Soviet network, impossible to keep track of. It worked. It went on combat duty. It is the one that got remembered. The road program was called Tselina, and the word is worth stopping on. Tselina means virgin land, untouched soil. It was the name of Khrushchev's great farming campaign of the 1950s, the drive to plow up the empty steppe of Kazakhstan and turn it into wheat. Every Soviet citizen knew the word. It meant tractors and grain and posters of young people going east to build something. They gave that name to the nuclear one, and the first machine built under it would be tested in Kazakhstan, on the Virgin Land itself. The first attempt was finished in June of 1983, and the numbers on their own do not land, so try to picture it. The Mars 7904. 6 axles, 12 wheels, and those wheels were roughly 3 meters in diameter, taller than the room you are sitting in. The vehicle was over 32 meters long. It weighed 360 tons loaded and carried 220 of that on its back. The engine was a 42-liter V12 diesel, 1,500 horsepower. And here is a small detail worth holding on to, because it comes back at the very end. That engine had originally been designed for ships. There was a second engine as well, a smaller one, purely to run the machine's own systems. The thing needed an engine to look after its engine. Testing began the way everything in this program would be tested, at night. And only when the military confirmed there was no foreign satellite passing overhead. Think about the arithmetic of that. A vehicle the length of 2 buses, on wheels taller than a man, moving through a Belarusian night in a window of minutes calculated from orbital tables. Somebody, somewhere, was keeping a schedule of when the Americans could see. In January of 1984, they took it apart. Not because it had failed, because it could not be driven anywhere. It was too heavy for ordinary roads and too big for ordinary bridges, so they dismantled it, loaded it onto a special trailer, shipped it to Baikonur, and rebuilt it in Kazakhstan. And in February, on the open steppe, they found the flaw. 60 tons. That is what each axle was pressing into the ground. For scale, a loaded articulated lorry on a European motorway is limited to somewhere around 10 tons per axle, and that limit exists because above it, roads stop behaving like roads. This machine was putting 6 times that through every axle, and it was not built for motorways at all. It was built for the places motorways do not go. Out on the steppe, that arithmetic came due immediately. The wheels did not grip. They compressed. The machine dug in rather than pushed forward, and it handled badly, and the ride was rough enough to be a problem in itself, because the thing on its back was not cargo. It was a warhead. And this is the part that says most about how the program actually worked. They built it first. 360 tons of machine, designed, fabricated, assembled, dismantled, shipped 2,000 kilometers, reassembled. And only then did they discover by driving it that it sank. The Mars 7904 never left Kazakhstan. When the requirement moved on, the machine stayed where it was, parked at Baikonur, slowly going the color of the steppe around it. The Soviet Union collapsed. Baikonur ended up in a foreign country. Russia leased the site from Kazakhstan, and the lease covered, among 10,000 other things, a rusting 360-ton vehicle nobody had a use for. It was finally cut up for scrap in 2010, 26 years after it arrived, 19 years after the country that built it stopped existing. The requirement, meanwhile, had changed. The missile was upgraded, and the road program was reissued under a new name, Selena 2. Same idea, higher standard, and a much harder weight target. The second attempt came in the summer of 1984, the MHZ's 7906. 8 axles now instead of 6, wheels of a normal size, 26 meters long, the same 1,500 horsepower diesel now doing the work of 2 engines. It was a genuinely better machine. The load on each axle came down from 60 tons to 27.5. The military said no again. 27.5 tons per axle was still more than the ground would take, and the consequence was not abstract. It meant prepared routes. It meant reinforced surfaces and checked bridges. A weapon that can only travel where the state has strengthened the road in advance is not really mobile. It is a fixed weapon with a longer setup time. So in 2 years, the program had produced 2 enormous vehicles, consumed an enormous amount of steel and money, and arrived back at the same wall. Which left one idea. If the problem is how much weight each axle puts into the ground, stop arguing with the weight. Add axles. The first MHZ 7907 was finished in March of 1985. 12 axles, 24 wheels, every one driven, 16 of them steering. The 4 front axles and the 4 rear axles turning in opposite directions, so that a machine 28 meters long could come around in a circle 27 meters wide. It could turn in barely more than its own length. The drivetrain is the part that still sounds like science fiction. There was a gas turbine, taken from the family of engines that powered the T-80 tank. But that turbine was not connected to the wheels at all. It spun a generator. The generator fed electricity to 24 separate motors, one inside each wheel. Every wheel also had its own independent hydro-pneumatic suspension, so the machine could crawl over ground that would have grounded anything rigid, each wheel finding its own level. And because there was no mechanical link between turbine and road, something remarkable followed. You could kill 8 of those wheel motors, a third of the machine's drive, and it would keep going. For a vehicle meant to operate after a nuclear exchange, on roads that might no longer be roads, that was not a specification. It was the whole point. It is worth asking why nobody in the West built anything like this, because the answer is not that they could not. The Americans went down the roadmobile path too. They developed a smaller missile called Midgetman, and for it they built an enormous hardened launcher, a machine designed to survive the blast wave of a near miss and keep driving. They tested it in 1989, but nobody in the West attempted this particular solution. 150 tons of payload carried on 24 separately driven wheels, with a turbine generating electricity for every one of them. That layout existed in exactly one country. There was, however, a problem, and by one account, the way they solved it was extraordinary. The frame was flexing. A spine that long, carrying 150 tons, bent under its own load in a way that was not safe and was not going to get safer. And according to the Russian technical press, the engineers did not go back to the drawing board. They took the frame they had and cut it into 2 equal sections, then installed a horizontal joint between them, one that let the 2 halves move against each other by up to 8 degrees. The factory's own account is less dramatic. It describes the chassis simply as 2 6-axle sections joined by a hinge, as though it had always been designed that way. Both descriptions end at the same machine. It stopped fighting the ground. It started following it. Finished length, 28.1 meters. Empty weight, 65.8 tons. Rated load, 150. Top speed, 25 kilometers an hour. Which sounds like failure and is not. Not quite. This machine was never meant to outrun anything. It was meant to be somewhere unpredictable when the warning came. 25 kilometers an hour, sustained, through forest, at night, is enough to be 40 kilometers from where the enemy last saw you by morning. It did not need to be fast. It needed to be gone. Factory trials came first. 1,000 kilometers, run on a proving ground and on the Mogilev Highway in the dark. Then, in September of 1986, the machine went to the army. They took it to a place called Vypolzava in the Tver region, a base belonging to the 7th Guards Rocket Division. Today, that place is called Ozyorny, and it is what the Russians call a closed administrative territorial formation, a town you cannot enter, built around something you are not supposed to know about. For most of its existence, it was not on the map at all. They built things there specifically for this. Sheds to hide the machine in, sections of road for it to drive on, bridges, actual bridges, constructed so that one experimental vehicle could be driven across them at night to find out whether it could be driven across them at night. The trials ran a year, September 86 to September 87. In that year, the Mahaz 7907 covered 2,054 kilometers. And here is what that number means. The rail version of the same missile, the train, the one that made it, ran endurance trials across the Soviet Union in climates from the Arctic to Central Asia and covered more than 400,000 kilometers. 400,000 against 2,000. That is not a gap in performance. That is a gap in belief. One of those programs was being proven, the other was being observed. And the comparison at Vypolzava was not against the train anyway. It was against its own sibling, the 8-axle 7906, running the same roads on the same nights. Two Belarusian giants in a forest in the dark being measured against each other for a job that, well, we will come to that. Technically, the trials found that the 7907 was the better machine, better maneuverability, better survivability. The engineers had done what they were asked. The comparative trials closed in September of 1987. 1 month later, on the 20th of October 1987, the 1st Rail Regiment of the same missile went on combat duty at Kostroma. Read those 2 dates again. The road version finished its evaluation in September. The rail version was deployed and armed in October. You do not go from a test result to an operational nuclear regiment in 4 weeks. By the time the road trials ended, the railway program was not merely ahead of it, it was already going into service. And if you are being fair about it, and I think you have to be, the rails were the better answer. The Soviet railway network ran to well over 100,000 kilometers of track. A missile train could vanish into that in a way no road vehicle could, because the network was enormous, because ordinary freight moved along it constantly, and because one more set of goods wagons is not a thing anybody looks at twice. The train could cover 1,000 kilometers in a day. It could stay out for weeks. The road machine could manage 25 kilometers an hour and needed prepared routes to do it. Which is what those bridges at Vypolzava were for. They were not testing whether it could cross any bridge. They were building it bridges it could cross. So the generals were probably right, which does not make what happened next any less strange. Here the story gets genuinely strange. And I want to be honest about the limits of what is known. There is no published document that closes this program, no decree with a date on it, no minuted meeting where somebody says the words. Soviet strategic programs were not wound up in public, and the paperwork has not been released. What exists instead is 4 explanations, from 4 organizations, with 4 different things to protect. The missile's own design bureau, the people who made the RT-23, the same bureau you will have met if you know the story of the nuclear train, say the road complex was stopped because it could not have delivered the combat effectiveness required. In other words, even working perfectly, it would not have been good enough. The research institute that ran the trials says something narrower and colder. Both chassis failed to meet requirements. No method had been found, in theory or in experiment, to fix the ground pressure problem. Further development was unpromising. The factory that built it says something else entirely. The historians of the Minsk plant record that the machine met its specification in full, that the commission recommended it for production, and that the project died because the missile went to rails instead. So, the institute wrote that the machine was not good enough. The factory wrote that it was recommended for production. Both of those documents exist. They are about the same vehicle. And the 4th explanation is the one you can feel underneath all the others. The Cold War was ending. The money was going. Weapons on this scale stopped being necessities and became luxuries, and there was nothing left to maintain a luxury with. I do not think these are competing accounts. I think they are 4 floors of the same building. At the bottom, a physical problem the engineers never fully closed. Above it, an operational judgment that the concept was not worth closing. Above that, a decision already taken in favor of a rival platform that worked. And over all of it, a state running out of the ability to pay for any of this at all. Nobody killed it. Everybody did. There is one more coincidence, and I give it to you on the condition that you treat it as one, because that is all it is. The first MHZ 7907 was assembled in March of 1985. That same month, a man named Gorbachev became General Secretary of the Communist Party. There is no causal line between those two facts. They simply happened at the same time. Boris Shaposhnik, who had founded that design office 31 years earlier and run it ever since, died that same year. He was 82.
Which brings us back to the boat.
Summer 1996. 5 years after the Soviet Union stopped existing. A commercial firm in Belarus had bought a river passenger vessel, 40 meters long, 88 tons, and wanted it on Lake Narach, the biggest lake in the country, pine trees and water and holidaymakers. It was going to be a floating restaurant. The boat was on the Berezina River. The lake was 250 kilometers away. And there was exactly one object in Belarus capable of moving 88 tons of ship across a country. But here is the part I have been keeping from you. The Mars 7907 was not supposed to drive. The plan was to use it as a trailer, an enormous 24-wheeled platform towed by a separate prime mover, an 8-axle MZK-T tractor, a serious machine in its own right, the kind of vehicle that pulls missile launchers for a living. The 7907 would carry. The tractor would pull. The tractor made it about 30 kilometers, and then it broke down. Not on the return leg, not after the hard part. It failed on the way to collect the boat, before the load was even on. So somebody stood on a factory yard in Minsk, looked at a dead tractor, and looked at the machine that had been sitting there since 1987 with a cancelled program behind it and nothing at all in front of it. And they woke it up. They stripped off the missile mounting and fitted half-round cradles in its place, shaped to hold the hull of a pleasure boat. The trailer was going to have to be the truck. What followed was, by any measure, a serious piece of engineering. 250 kilometers across Belarus in daylight. Power lines along the route had to be switched off and lifted so the ship could pass beneath them. Sections of road had to be reinforced before the convoy reached them. Bridges were crossed on temporary decking, with winches taking part of the strain. 8 years earlier, this machine had only been allowed to move when the satellites were somewhere else. Now it was crossing a country in broad daylight, at about 20 kilometers an hour, in front of anybody who cared to stop and look. And it held, all the way. They reached Lake Narach. The boat was delivered. The restaurant got what it paid for. Then they had to get 88 tons of ship off the back of it. So they drove it into the lake. I want to be clear that this was not an accident. It was the method. To float a hull off its cradles, you reverse the carrier into the shallows until the water takes the weight. It is how you launch a boat with a truck, if the truck is large enough. It worked. And then they turned around and started home. Somewhere on that return journey, the machine began to die. Water had got where water should not be. The transmission components started failing, one after another, and each failure took another wheel with it. By the middle of the road home, not one of the 24 wheel motors was still turning. They towed it back to Minsk. The machine built to survive a nuclear exchange was disabled by a Belarusian lake on a catering job. 2 were built. After the lake, both sat on the factory grounds for a decade, neither of them whole. In 2006, the plant took the parts of the 2 and assembled one. The design office did not die with the Soviet Union. In February of 1991, it was separated out of the parent factory and became a company in its own right, the Minsk Wheel Tractor Plant. The same bureau Shaposhnik founded in 1954. It is still there. It still builds enormous wheeled chassis for missile systems. It is wholly owned by the Belarusian state. It sits under international sanctions, and its products are underneath Russian launchers being used right now. The machine did not survive. The capability did. In October of 2021, the plant opened a museum, a small building and an open yard outside. And in that yard, restored and finished, stands the 28-meter machine on its 24 wheels. You can go and see it. but not by walking in. You apply at least 3 working days in advance. You come on a weekday between 9 and 3. You are issued a temporary pass at the gate, you are given a safety briefing, and you cross a working military factory under escort. 15 people at a time, nobody under 14. The secrecy is gone, the procedure remains. 2 prototypes, 2,054 kilometers, 1 boat. And a machine built for the end of the world, which never found anything to do, until somebody needed a restaurant moved across a country. Thanks for watching.